Find an equation of tangent line. So we're going to need a point here. So I did not see that point here, but I will just add one point here. So you can kind of use that to adjust your equation. Okay, so first we're going to need a derivative because derivative is going to give us a slope, right? So I will just do y prime, which is going to be by product rule because this is 6x is one function and arc cosine is one function. So using the product rule, so derivative for first function is 6 times arc cosine of x minus 1 plus derivative of arc cosine is going to be derivative of inside, and then you take the opposite of that, so that's negative 1 over square root of 1 minus x minus 1 squared, and then times the first function, which is 6x here. Okay, so now you have 6, I'll just write this as like cosine inverse of x minus 1, and then when you multiply these two things, so you get negative 6x over square root of 1 minus x minus 1 squared. So this is your derivative. So the equation of tangent line, so equation tangent line at that point on the graph. So let's call this point x1, y1. It's just this y minus y1 equal m times x minus x1. Like I said, I did not see x1 in your image. In the image you sent, there was no x in the point was specified. So here, for instance, if I just, like let's say choose a random point, let's say I'm going to choose x1 to be 2, or maybe let's just choose x1 to be 2. Okay, so if your point is different, then just adjust it. So if x1 is 2, then what I will do is first find the y1, and to find the y1, you're going to plug this into the equation. So you're going to do f of x1. F of x1 is y1, right? It's going to be the y value. So plug 2 in this equation, which is 6 times 2 cosine inverse of 2 minus 1, which is 12 cosine inverse of 1. And cosine inverse of 1 is going to be 0 basically, right? Cosine inverse of 1 is 0. Then you'll get 12 times 0, which is 0. So your y1 is now 0. And then to find the slope, so I compute the slope already, I compute the derivative, I'm going to plug x1 into this equation. So if I do that, f prime x1, which is a slope, right, which is m here, and then that's 6 times cosine inverse of 1 minus 6 times 2 over, okay, I think we have a problem here, so it could be better if you choose a different point because we don't want a 0 here, right? The bottom turns out to be 0 for this number, right? But we don't want that to happen. So maybe we can change that number to something else. Like, let's say you can change it to be, maybe I can change it to be 1/2, or maybe 1/2. Yeah, so let's change this to 1/2. If this is 1/2, so of course we have to adjust this again. So the reason I change it because I don't want the denominator to be 0 there. So I can change it to 1/2. Now we can compute y1, and y1 is just going to be f of, that's just 6 times 1/2 cosine inverse of 1/2 minus 1. This is 3, and then this is cosine inverse of a negative 1/2, which is 2 pi over 3. So 2 pi over 3, so that's 2 pi. Okay. So this is 2 pi. So y1 is 2 pi, and then we're going to plug. I'm going to compute this again. Let me just plug 1/2 there. So this will be negative 1/2 again, minus 6 times 1/2 over, and this will be square root of 1 minus 1/2 squared, and this will be 1/4. So then you'll get 6 times 2 pi over 3 again, minus 3 over, and this one is square root of 3 divided by 2, which you can simplify this. So that's 2 minus 6 over root 3. So that's going to be 6 over root 3. And you can simplify this if you want to. So what I'm trying to say here is, so this number, you can adjust it. So that's really, it doesn't matter. So now y minus y1, I find it 2 pi. this is the slope, but you can simplify this, like I said. 2 minus 6 over root 3 is the slope, times x minus x1, which is a half. That's going to be your equation, which can also be simplified. Okay. I hope you get the idea. So we compute a derivative and plug the x1 in the derivative function to get the slope, and I plug x1 into the original function to get the y1, and then I simply just use this equation to write the equation of the tangent line.